I gave myself a challenge to make a video game project in the month of February. Here's the process. First off, I wanted this to be a challenge, so I came up with 3 different ideas. The first one being 2-button controls, the second one being Pursuit, and the third one being Souls-like. So, what that means is I'm only allowed to create a game with 2 buttons, attack and dodge/parry. Next up, the game is going to be a pursuit theme, so the character is pursuing something the entire time in the game. And then finally, Souls-like, I wanted to collect score when dying, infinitely scroll and boosting in complexity challenge, and then settings like the current setting here was just a dark Souls-like kind of a setting. So this is the second day of development here. This is what I have. We have an infinite parallax background, we have an attack animation for the character, and an infinite run animation, as well as a hurtbox for the character. Same day, we also have added a representation for a future enemy coming towards the player. Here we are at the 3rd day of development. Now we have the actual enemy added along with the hurtbox for the enemy, and we also added a game speed mechanic that every single thing bases off of. So we can gradually increase the speed of the game as we play, and this goes infinitely, as you can see. For the 4th day of development, we have now added an air attack. As you can see, we can deflect the objects that the air attack does, and now we can attack and actually kill the enemies that are coming on the ground. Day 5, the object that has been deflected now detects if it hits an enemy and it deletes the enemy. For the final day of development, we added different landing zones for the air attack. We had to update the deflection logic to make sure it hit the enemy. And then we also added the enemy will now fly away if the deflection isn't landed, so it doesn't just linger there in the screen. Anything that leaves the screen deletes in memory. Anything that dies from either a deflection or an attack also gets deleted in memory. Obviously, this is not like a full game that people can play, just a little concept. However, the previous 3 months, I had been just consistently learning. I never really actually made any projects during those 3 months. I mean, I had made like a particle physics simulation, and I also had made Axis Aligned bounding boxes, but majority of that time was just spent really sharpening my ability as a programmer. And so February, I just wanted to make something and have something to show on the channel for you guys. And so what's coming up next? Well, I need to learn Django for a class. And so I have this big ass book here, and I'm thinking, I wonder if I could make something in Django that could be considered a video game. And now my first initial thought is something like a adventure game, which that's super easy. So we may make an adventure game, or we may kind of step up the complexity. But if you stayed awake to the very end, thank you very much for watching. Hope you'll have a great day. Please leave a like, please subscribe. It really, really helps me out. I want to make this channel something that is big, something that doesn't follow what everybody else does, something that does a different route from everyone. For example, this Django project. So thank you very much again. And for the people who enjoy looking at code, the remainder of this video is going to be looking at the code and talking about it. So if that's not your thing, then take care. Alright, code weirdos. This is what we got. These are all my include files. We're using Raylib for the project. Raylib's my main video game development framework that I use. And so the big part of this project was that I wanted as much of the video game logic as possible inside of classes. What that means is really nothing is being handled in the main loop here at all. So this was like a major accomplishment for me so far in my ability as a programmer. And so first up, what we're going to look at is, let's go ahead and start simple with the asset manager. And so we have all the assets here. We're using a vector for player textures, enemy textures, and UI textures. This is the background, midground, foreground, and walkway of the game. This allows for the parallax background, and this really only just loads and unloads textures. Next, let's go ahead and look up the UI. So we have when we create the UI, we're including the background, midground, foreground, walkway, screen width, and screen height. And then this is how we have our parallax background set. We're just incrementing by the offset. And then we've got some for loops to draw the textures. Next up, let's go ahead and look at the engagement manager, which handles all the collisions. And so we have, in here, we have a vector for the enemies, and then a player. And then when we create the engagement manager, we're putting a vector as an input for the enemies. Let's go ahead and go back to main real quick. Whenever something spawns, we are adding to this enemy's vector. And then it applies literally to every single thing, the collision manager, stuff like that. This is the actual collision manager here. It's a simple collision system because we don't have to move things around at all. We just are detecting if something is entering a hurt box. A hitbox enters a hurt box. So this did not implement any of the stuff that I had learned previously in projects, but it helps. And then this is for here, iterates to the enemies to check if attacked or projectile lands, and then delete the enemies. So this is the player attack and the projectile hitting the enemy. Either attacked, or it hits enemy, or if it leaves the screen, delete it. The iteration. Dot erase. Next up, let's look at the player here. We're going to start at the class declaration. We're putting in textures and the enemy's vector as inputs when we create the player. Then we have an enumeration here for the player state. So we're using a state case system for the states of the player, and that basically is going to update. Let's look at the code. Depending on the state, there it is. Switch state. Yeah. So depending on the state is the texture, and then the source dot width. So the size, which I think this is not necessary as code anymore because I went in and I changed all of the textures have the exact same height and width of frames. And then hitbox, attacking, this is the we'll show that in a second. But basically when the player attacks, the hitbox shows, and then when we leave the state, the hitbox goes away. And then drawing the texture here inside main, and then enemy, we'll go into enemy, kind of similar except we're just using vectors. So we have an enumeration for the enemy states, attack and air attack. We're feeding the textures into the enemy anytime we create an enemy. Same thing, update, draw. Go ahead and look in the functions of the enemy. Timer, delta time, etc. And then as far as the states, this is the state system, should be under update. Yep. And then we're passing a reference of the player in so we can detect interactions between the enemy and the player. And then we have the texture changes for both attack and air attack. And we're going to do actual updating of attack if it's a normal attack. And we have a separate one for update air attack. The air attack pattern is different for the AI logic of the enemy. And then we're using, well, initially we tried using a random system for the spawning, so it just randomly spawned within a certain square. However, there was still overlapping, so we changed it to a system of position index, which I believe is in the main. Yeah, flying position, and we have a enumeration for that as well. And then the positions are basically pretty much just like plus or minus 50 of the x and y coordinate, etc. And then shooting the projectile of the air attack using games, it feeds game speed in. This, because earlier we mentioned that everything is based off of game speed. And the projectile deflect, updating of the projectile itself, drawing of the character, and then setting the attack state or whatever. Yeah, for under main when we create the enemy. Let's see if we can find that real quick. And then what else can we show? I believe that is it. Let's go ahead and run it real quick. And then I'll go ahead and show you game speed increasing, deflection. We have the multiple different parts that it can land at. So far it looks like it's only choosing 2, but there should be 4. Yeah, broken code. It's okay though. So yeah, this was a really fun project to make. I'm going to end this project from here on. I have other things I need to work on, especially for school. But this was good, a good project to make. So thank y'all for watching. If you're one of the people who like watching code, I appreciate you watching, looking through. If you see anything that could have been done better in the code, feel free to let me know in the comments. I stream development, so if you ever wanted to pop in and even give me like some tips or ideas that you would add into the game itself, people do that a lot, and I really appreciate that. Please do that as well. Thank you. Take care.